For centuries, the ultimate currency of national power was tied directly to the number of human bodies a state could field, sustain, and, if necessary, sacrifice on the battlefield. But human infantry faces an insurmountable bottleneck. Biological systems require complex logistics to survive. Their cognitive performance degrades under fatigue, and they remain entirely vulnerable to chemical, biological, and radiological environments. This paradigm is shifting. The deployment of the Phantom Mk1 marks the first time autonomous infantry has moved from testing labs to active combat zones. Modern militaries are beginning to transfer their primary operational constraint away from biological risk. On the automated frontline, tactical success is governed by raw manufacturing output. The Phantom Mk1 utilizes a 176-pound chassis, standing 5'9", encased in high-durability alloy plating designed for frontline resilience. At $150,000 each, these units are a fraction of a human soldier's lifelong training and healthcare costs. Industrialized forces scale through production velocity, expanding an initial 40-unit deployment toward 50,000 units to meet demand. However, mass-producing these machines only solves the problem of cost. Once deployed, they face a physical navigation challenge that has stalled robotic warfare for decades. Manufacturing capacity serves no purpose if the machines cannot navigate the staircases, doors, and complex debris fields found in modern urban combat. Urban operations, specifically building breaches and subterranean clearing, historically rank as the most lethal environments for human forces. Previous robotic platforms utilized wheels or tracks, leaving them bottlenecked by vertical obstacles and narrow door frames. They were physically incompatible with these spaces. Every door handle, every industrial ladder, and narrow corridor is designed around the human form factor. Mechanized units have struggled for half a century because of this mismatch between their hardware geometry and human-centric architecture. The industry-wide pivot toward humanoid robotics is a pragmatic software integration strategy. By standardizing on the human form, defense contractors avoid the billions required to design custom hardware for every niche task. It allows them to deploy generalized AI directly into existing physical systems. The Phantom Mk1 can mount explosives on reinforced doors, climb industrial ladders, and operate standard service weapons without requiring hardware modifications. In this framework, the human body plan is the ultimate open-source legacy interface. It is the most efficient way to deploy autonomous systems into human infrastructure. Mimicking human geometry allows these machines to bypass the physical constraints that once restricted automated units to open fields and flat roads. Beyond the kinetic power of the robot lies a geopolitical disruption known as the scaled war paradox. Projecting lethal power without risking human lives significantly drops the domestic political cost of entering a conflict. Hardware attrition is a budgetary line item, while human casualties create intense political pressure. Losing a humanoid chassis is a simple manufacturing replacement. This changes deployment speed. Traditional forces require months of mobilization, while localized autonomous assets activate on demand. This creates a dangerous asymmetry. With such a low barrier to entry, nations may enter and sustain prolonged friction points with very little internal resistance. By removing human risk from the equation, autonomous infantry effectively destabilizes the diplomatic deterrence frameworks that have governed global security for decades. This shift is occurring in 3 phases. Currently, in Phase 1, bipedal robots serve as reconnaissance and high-risk logistical buffers to insulate human soldiers from direct fire. By 2028, Phase 2 will introduce mixed squads. Human operators will command local networks of autonomous platforms that perform dangerous building breaches and mine-clearing tasks. The final escalation arrives with Phase 3, fully autonomous machine-on-machine engagements. In this stage, robotic processing velocities will exceed human cognitive redaction limits. Maintaining operational advantage requires removing the human decision-maker from the loop entirely. Strategic survival will depend on edge compute resilience and strict algorithmic compliance protocols, safeguards ensuring machines remain bound by international regulations even when disconnected from networks. The age of biological warfare exclusivity has ended. The code is live, the machines are on the line, and the front line is now a matter of manufacturing and math.